Hello, and welcome to another episode of MAIN-iac Science Lab with your host, me, Mr. Andy, Youth Services Librarian at the St. Johns County Public Library System, right here in St. Augustine, Florida. And today, we are going to have some fun. We are going to talk about volcanoes. Oh, yeah. Look at those things. They're so huge. Do we have volcanoes in St. Augustine? I don't think so. I've never seen one. I've seen some interesting eruptions from the ground at the beach at low tide, but I don't think that has anything to do with volcanoes. So let's get into it. Beneath the surface of the Earth, or the crust of the Earth, is a layer of molten rock known as the mantle. There are thin sections of that crust known as hot spots, where their molten rock, called magma, can burn through the crust and create a volcano. So you've got your crust, you got your mantle down below it, and the hot spots are the weak sections. And when they get weak enough to break, get yourself a volcano coming through from underground up above the ground. So we tend to think of volcanoes as mountains, but they don't really start out that way. Magma that is released through the Earth's crust is known as lava. And as the lava erupts, it cools and builds up layers that can eventually form into the shape of a mountain. So let's take a look at a diagram of the Earth. Here we go. I think my picture might be in the way, but you get the better idea of it. Out here, we have the outer layer, which is the crust. The inner layer, which is the mantle. That's where the hot magma hangs out. There's also the outer core and the inner core. We won't get deep into that, but just suffice to say, it's crazy hot down there and you don't want to visit. So the mantle's full of hot molten rock, and the crust has weak sections in it called hot spots, where that molten rock can pop through, turning that magma into lava, and then it can create volcanic eruptions on our surface. And you know, the Earth's surface, the crust, is not just one solid layer across the planet. Actually, it's a bunch of different tectonic plates that are floating around on top of that hot, flexible rock. And volcanoes tend to exist in areas where these plates bump together and pull apart. That's where the weak sections come up. So one of the most famous tectonic plates is called the Pacific Plate. That's this one right here in the center of this graphic. And it's also known as the Ring of Fire due to the numerous amount of volcanoes all around the outside of that plate. There are 452 known volcanoes along the Ring of Fire. Pretty wild, huh? Well, lava can get pretty hot. It can reach temperatures as high as 2,200 degrees Fahrenheit. That is way more hot than you and I should ever hope to experience in our lifetime. Just think, your oven only goes up to like 500, maybe. If it's a super fancy oven, it might get a little hotter than that, but 2,200 degrees Fahrenheit, that's hot. The good news is, once that lava touches the atmosphere, the air, once it escapes the Earth, it cools down really quickly, which is very, very helpful to us. So when lava escapes the volcano, it can seep out slowly, like it is in this picture, and just kind of flow slowly across the ground. Or, like in this picture, it can explode violently into the air. This occurs when there's a lot of pressure that builds up until the volcano literally blows its top. Now, when the volcano explodes, it can send lava, rock, gravel, dust, and poisonous gases all up into the atmosphere, which is eventually going to come back down and land on the surface. Some volcanoes send out rocks that are so big, they're the size of houses. These are known as bombs. I think you can figure out why. When one of those lands on the ground, it's going to make some noise. They also can send ash that can coat the land for miles around, turning everything around the volcano into a sea of gray and white dust. Pretty wild and really kind of freaky to see. We have a lot of books at the library on volcanoes, and they'll show you a couple pictures of some cities that had dust like this just spread everywhere. Next, we want to talk about low pressure volcanoes that slowly seep or leak the lava. The eruptions are not nearly as violent. They're actually pretty easy to escape due to the slow moving nature of the lava. It's just kind of creeping along, so you can run away or drive away pretty easily. The explosive ones, you definitely want to be out of the area before that happens. But the slow seepers, not quite so dangerous, easy to get away from. However, some of these volcanoes that seep slowly can also slowly seep poison gases. Oh, there's that ashy landscape. Yeah, pretty crazy looking, huh? Now, those seeping volcanoes, when they seep the lava slowly, they also seep gases slowly that can leach into nearby waterways, turning those waterways into dangerous lakes of acid. So dangerous that it can dissolve skin and bone. Definitely don't want to go for a swim there without testing the waters first. No way. Now, there are also many volcanoes that exist deep under the sea. In fact, about 75% of all volcanic activity occurs under the ocean. And it takes millions of years for a volcano to erupt enough to build itself up into an island. When a volcano erupts undersea, the magma gets cooled pretty quickly by the ocean water. So it continues piling upward slowly instead of just flowing away. And sometimes, if you're lucky, you can see a volcano being born. In 1963, a fisherman near Iceland was lucky enough to witness a volcano being born out from under the ocean. He was in his boat and he literally saw the volcano appear in the water. How cool would that be? Well, this island here is that volcano. It is called, where are my notes? It is called Surtsey, named after Surtur, the Norse god of fire. And just a few years after that volcano erupted out of the ocean, grass began growing on the island and birds and seals had moved in to make it their home. Pretty cool, huh? Man, it'd be cool to be that guy watching that happen, because that's a once in many lifetimes experience. Now, not all volcanoes are active. Some are sleeping and some are completely extinct, meaning that they will never erupt ever again. Mount Fuji in Japan, which is what we're seeing here, is an example of a sleeping volcano. It was last active in 1770. It's like 250 years ago, but it could explode at any time. Wow, how scary. If Mount Fuji was to explode, that would be devastating to the city of Tokyo and the millions of people who live in the general area. Rest assured, I'm pretty positive that scientists in Japan are keeping a very close eye on this one and looking for any crazy activity to let them know that it's time to go. So there are many famous volcanoes that you can research if you are interested in learning more. Mount Fuji, Mount St. Helens, Montserrat, Mount Pinatubo, and Krakatoa are some of them. This one here is Mount Vesuvius in Italy. Now, you may or may not know the term Mount Vesuvius, but I'm sure you've heard the term Pompeii. Mount Vesuvius erupted in 79 AD in Italy, and it rained hot ash, lava, dust, and clouds of deadly gas onto the towns of Pompeii and Herculaneum. Both towns were buried from that for over 1,600 years. Much of Pompeii, believe it or not, is still intact. It was preserved in ash and provides an enormous wealth of information about everyday life in this ancient Roman town. In fact, this is an image of many of the structures from that town that have been excavated in recent years. Pretty cool, huh? Well, the library has a lot of books about Mount Vesuvius and about Pompeii, as well as many of these other famous volcanoes. And you should check one out today. You can go online and make a reservation anytime you like. Here's some examples of books that we carry, but I know there are many, 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 many more. These just happen to be ones that I had on hand at the time. So you can check one out, go online, reserve your copy, and then go pick it up at your local library. So that is our brief history information lesson on volcanoes with MAIN-iac Science Labs. Now on to the fun part. Yes, sirree. We are going to, once I figure out how to stop screen sharing, there we go. I'm back. Hello. Now we're going to do an experiment that has nothing to do with volcanoes, but it looks like a volcano when the reaction occurs. So I'm going to do a double thing here. I'm going to show you what it looks like when a volcano erupts. I'm also going to teach you a little bit about acid-base reactions. So if you want to participate in the experiment, you really only need a couple things, and most people have these things in their home, easily accessible. So time to go run and find these things as I tell you about them. The first thing you're going to need is some straight up distilled white vinegar. You have some of this in your kitchen, your pantry, or your laundry room, you're good to go. You don't need a lot either. You also need some baking soda. A lot of people have this to keep the smells out of their refrigerator or out of their cabinetry, or if you have a pool, sometimes you use it to mess with your pH balance. So see if you can find some baking soda. Not necessary, but super cool if you did have it, and I'm sure you do. Some dish soap, because we're going to try an extra layer to our experiment and show you what can happen when you add this to it and how it changes. You will need some food coloring, whatever color you want your lava to be. Grab some food coloring. Absolutely not required. If you don't have any, don't worry about it. The experiment is still a lot of fun. It's just you can make it colorful if you want to. I'm going to use some red. It's not really going to look like lava, but it's the closest I'm going to be able to get with my simple household materials. You're also going to need a 1 tablespoon measuring spoon. You're going to need a 1 cup measuring cup. You're going to need a glass, an empty one. And I actually recommend, if you have access, have several glasses on hand, because we're going to do this experiment a couple of times, and we don't want to have to stop and go clean each glass in between experiments. So if you're able to, get a couple, like 4 or 5, and then when you're finished with one, you can set it aside and start over with the next one. It'll make your life a little easier. If you only have the 1 glass available to you, not a big deal. You're just going to have to go rinse it out in between experiments. Not a problem. The most important thing, if you're doing your experiment indoors, and I'm doing it on my nice new dining room table, you need some protection for that table. The easiest protection would be a simple baking sheet, the important part being the edge, the rim. Because what we're going to do is we're going to have a volcanic eruption, small scale, nothing shooting into the sky. I don't have to worry about that. It's just going to be erupting out of the glass, and this will catch the eruption for you. A standard size baking sheet like this one should be plenty big unless you get a little bonkers with your mixing. So follow the instructions I give you and you should be just fine. If you have a plastic tub that has a snap-on lid, that should work fine too, as long as there's a ridge around the end to prevent spilling. Now, Miss Marcia and I did this experiment several times, and we used the same lid over and over and over again without having to worry about spilling. So it's really not a big deal, just good to be a little safe to make sure you're protecting your furniture, especially if you're using food coloring, because that can make some staining pretty intensely. Yeah, it gets on everything. So, are you ready to begin? I am. I'm super excited. So, I have my first glass, and this is what we're going to do. First, we're going to take 2 tablespoons of baking soda. So that's where your tablespoon thing comes in handy. And baking soda gets to be a little chunky. So if you're able to access it, you can kind of break it up a little. But I like to pour over the glass in case there's spillage. Hopefully not too much, because that can mess up your experiment. We're trying to be scientific here. So literally, you want 2 tablespoons worth of this. And it can be approximate. We're not we're not creating the greatest new vaccine in the world here. We're just having some fun. So if you're not precise in your measurements, it's okay. Now, when you want to change the world, you want to be a little more precise in your science. But for today, we're just having fun. So let's approximate. Ooh, that's a little heavy. Let's see if I can put some. It's hard to put it back, isn't it? Let's try to put some back. Yeah, forget it. I'm just going to dump it in the glass. There we go. So we got our baking soda in the glass. Now, set that aside somewhere where it's not going to get dirty. Now we need our 1 cup of vinegar. So you have your 1 cup measuring cup. You have your vinegar. If you're a small person with little hands, and this is a big jug, get someone to help you so you don't spill it everywhere, because vinegar is stinky. You don't want to get it in your clothes and in the carpet and stuff like that. It does kind of smell kind of funny. So what we're going to do here is we're going to take this 1 cup of vinegar. We're going to pour it into this baking soda and see what happens. I'm going to skip the food coloring right now. But if you want to do the food coloring for this part, go ahead and add a couple drops to the vinegar and swirl it around so it mixes up really well. For this particular experiment, I'm going to go plain, so you see what it looks like without the food coloring. And then in future ones, as we do additional ones, I'll add some food coloring in so you can see what that looks like too. So what we're going to do is literally take the vinegar and slowly pour it into the glass, very slowly, and watch what happens. Whoa, it's fuzzy, fuzzy fizzing, fuzzy, fuzzy fizzing, and pouring out of the glass. Look, it's still going. And then it stops. That was exciting. And that was slow pouring. So what happened here? Let's get into the science of it before we continue with the fun. Baking soda and vinegar, actually, when you put them together, you get 2 separate reactions. The first reaction is an acid-base reaction. Baking soda is a base, vinegar is an acid. And when they are first mixed together, the hydrogen ions in the vinegar react with the sodium and bicarbonate ions in the baking soda. And the result is 2 new chemicals. 2 new chemicals, carbonic acid and sodium acetate. The second reaction then occurs, the decomposition reaction. The carbonic acid immediately begins to decompose, turning from carbonic acid into water and carbon dioxide gas. Now, carbon dioxide gas is what makes sodas super fizzy. And you saw the fizzing action happening here. The gas escapes the water and the gas separate, and the gas fizzes out everywhere, rising to the top and making what appears to be a volcanic eruption. Cool, huh? Yeah. So, here's an experiment. We've had our eruption. There's still baking soda in the bottom of the glass. What happens if we add more vinegar to the same glass? Let's give it a try, see what happens. Pour some more out of my measuring cup so I can have a little more control. Let's see if anything new happened when we do this. Nothing else has changed. Here we go, new vinegar. It erupted again! How cool is that? And I poured it in really quickly that time, so it erupted a lot faster. Whoosh! Pretty cool, huh? Now I've learned that you can probably adjust the amount of baking soda and the amount of vinegar you use, if you wanted to, and get similar or different reactions. We use 2 tablespoons of baking soda to 1 cup of vinegar, and we had our initial reaction. We added about another ½ cup of vinegar afterwards to the same baking soda and got another reaction. Do you think we can get a third one? Let's see. Kind of makes me wonder, is 2 tablespoons too much? Could you do the same thing with less? Baking soda is fairly cheap though, so it's not like you have to do it with less. But I wonder. Let's see if we can make it erupt again. Because you know when a volcano erupts, they tend to erupt multiple times. They don't just do it once and done, Well, sometimes they do when it's really explosive, like Mount St. Helens kind of just blew her top. Sometimes they erupt over and over again, intervals. So let's see if we can get a third interval out of our volcano. Let's see what happens. That's so cool. You can just do it again and again and again. How much fun is that? And I still have plenty of room in my tray to make even more mess. So I need somewhere to put this thing. Forgot to tell you about that part. Where are you going to put your glass when the experiment is over and you want to start a new glass? I don't know. Let's just stick it in the corner of the tray. Right over there. So we don't want to make a big mess. We don't want to spill everything everywhere. Put it over here. My tray's a little warped, so it's bouncy and moving. Okay, now we're going to take the experiment to a new level. We're going to add another ingredient. And this time I will use the food coloring to change the color. So I've got my new glass, nothing in it. We're going to add 2 more tablespoons of baking soda. Carefully. Beware of the chunks. That's approximately 1. And, geez, a little more than 1. So that's a little heavier than expected. Now this time, we're going to take some soap, dish soap. I'm using ordinary Dawn, but I think most dish soaps will work. We're going to just put a little splash into the cup. There we go. It's okay if it gets on the sides, not a big deal. And you just need a little splash. You don't need a lot. So remember what the volcano eruption looked like before. Now we're going to add some soap to the measure and see how it looks like after we add that. So we need more vinegar. Carefully pouring, trying not to spill. This time I'm going to add food coloring to see if we can make it a little more colorful. A little bit goes a long way with food coloring, so be careful, especially when you get it on your fingertips. Boy, howdy, it goes a real long way on your fingertips. You never really get a good orange, so I'm going to try add a couple different colors to see what we get. It's not really a volcano, but it'd be kind of cool if we can make it look kind of like a volcano. It's like a mostly red, a little bit of green, a little bit of yellow. It's kind of swirled in there a little bit. I can stir it up with my measuring spoon. Boy, that does not look anything like lava, but it's going to be fun nonetheless. All right, are we ready? We've got our baking soda, 2 tablespoons. We've got a splash of soap, and we've got our vinegar, pre-colored. What do you think the soap is going to do when the reaction occurs? Let's think about it scientifically. We know it's an acid-base reaction, which is going to form 2 chemical compounds. It's going to create carbonic acid and sodium acetate, and almost immediately, well, pretty immediately, the carbonic acid is going to decompose into water and carbon dioxide gas. Carbon dioxide gas escapes the water, flowing out very quickly in a fizzy mess. That fizzy mess is going to grab a hold of that soap. What happens when you mix up soap really quickly? It turns into lather, and it foams up. So this should be a foamy eruption, which will look a bit more like actual lava because it's going to be thick and creamy instead of just gas bubbles everywhere. So let's take a look and see what happens. I'm going to do this first one slowly and see how the reaction occurs. Let's watch. Slow reaction, not red at all, but look at that. Foam just kind of pouring out slowly, and it's still going. Whoa. That's cool. Not very red. I think I need more red food coloring. It came out kind of a cream soda-y color. You can experiment with your colors all you want. That's not really the important part. That's just visual. Yeah, that's pretty cool. Came out super slowly and thick, like lava would when it pours out of a volcano. So let's do it one more time with the same glass. Let's wait for it to slow down a little bit. We'll add some more vinegar to the same glass using the same baking soda for the next reaction. Keep an eye on your tray. This is our 4th experiment. The 3rd one has started to fill up my tray a little bit. I still have plenty of room to go before I have to breach the edge of the tray. So you may want to take a look at your tray and consider how tall the edges of yours are before you continue with the experiments. You may need to go dump it out and then start again fresh with a cleaner tray. But that just depends on the size of the tray that you used. My tray still got plenty of room, so I'm going to do this. I'm going to add a little bit quickly and see how crazy it goes. Quick dump, dump. Whoa, re-explosion pouring out of that cup. So foamy. Pretty fun, huh? I'm gonna do it again in just a second. Before I do, I'm gonna add some red food coloring in there and see if that makes any difference. I think it makes it looks cool. Probably not, because most of the food coloring is on the top. Maybe if I can get it to slow down and die down some. That might take a little while. So let's maybe, just maybe, when the vinegar pours in, it'll push it down some. Well, you know, there's one way to find out. Science. Let's do it. The second time I did this one, I only used a ½ cup of vinegar. I'm going to do another ½ cup. And I'll do it kind of slowly this time, see what it does. And a little quicker, it foams up, and comes out the top. And this time it's definitely more red, a little more lava-like, but it's very, very pinky red. Maybe I need to talk to Miss Alex and get some art advice with her on how to mix my colors appropriately to get the color that I'm looking for, which would be like a brownish orange. Maybe I just need more fancy food color. I don't know. So you can literally do this over and over again many, many times with the same class and the same amount of material inside of it. Just keep adding fresh vinegar, because the vinegar is where most of the reaction is occurring. It is reacting with the baking soda, but the vinegar is what's breaking down into the carbonic acid and then decomposing into water and carbon dioxide gas, releasing the bubbles. The addition of soap makes the bubbles foamier when they come out, so it looks a lot cooler and it lasts a little longer, kind of slows down the process some. But yeah, you could just do it again and again and again. Your only concern is whether or not your tray is going to overflow. So if you're outside, it's really easy. If you're inside, keep an idea on the water levels in your tray and have some fun making your volcano explode again and again. Should we do it one more time before we go? Yeah, let's do it one more time. This one's so much fun. I can't not do it again. Let's do it again. I'm going to do it quickly this time. It's going to be a big boom. Here we go. Ready? And eruption. Wow. Volcano pouring everywhere. Well, guys, I hope you enjoyed this episode of MAIN-iac Science Lab based on volcanoes. I hope you learned something new. And I can't wait to see you guys again. Stay tuned. In a couple of weeks, we're going to have another episode of MAIN-iac Science Lab. Who knows what we'll talk about then, but I'll post some information on the library web calendar as soon as I do. Okay, I'm Mr. Andy for the St. Johns County Public Library System. And on behalf of St. Johns County Public Library, this has been MAIN-iac Science Lab Explores Volcanoes. You guys have a great day. Have fun with your experiment, and I will see you next time. Bye.